All right. If you've ever found yourself an hour deep wrestling with some gnarly SQL joins just to get a simple answer, you know the feeling. Well, in this explainer, we're going to dive into how large language models are making that whole headache a thing of the past.
I mean, we've all been there, right? You're staring at a database schema, trying to remember the exact table names, the right join keys, all for a question that sounds so simple when you say it out loud. What if you could just ask your database the question? Well, that's exactly where this is all going.
Okay, so first things first, let's get on the same page. What are we actually talking about here? What even is a large language model, or an LLM? At their heart, you can think of LLMs as these incredibly powerful prediction engines. They've been trained on just a staggering amount of text from the internet, books, you name it. And from all that, they've gotten really, really good at one core task, predicting the next most likely word in a sentence. Now, when you scale that simple idea up, you get a model that can chat, write code, and summarize things in a way that feels, well, surprisingly human. So we've got this powerful model, but how do we actually use it? How do we have a conversation with it? Well, for most of us, the answer is an API, an application programming interface. It's the front door, the structured way we communicate. See, to get a useful response, you can't just throw words at it. We need to provide some structure, and we do that with roles. Think of the system role as the director on a movie set. It gives the LLM its motivation, like, hey, you are an expert SQL assistant. The user role, well, that's you asking the questions. And the assistant role is basically the LLM side of the conversation, which we use to keep track of what's been said. And the whole process is actually pretty straightforward. You build this list of messages, you fire it off to the API, and you get a new message back from the assistant, and then you just repeat that for every single turn in the conversation, which, if you think about it, brings up a really important question. So, if we're sending a new list of messages every single time, how on earth does the LLM remember what we talked about a minute ago? The answer is pretty cool. It's actually a clever illusion.
Okay, let's walk through it. For the very first turn, our application bundles up the system prompt and our first user question and sends it off. The model does its thing and comes back with, the capital is Paris. Simple enough, right?
Now pay attention because this is the critical part. When we ask our follow-up question, what is its population, we don't just send the new question. Our application takes the entire conversation so far, the system prompt, our original question, and the model's first answer, and then tacks our new question on at the very end. We're rebuilding the entire chat log every single time. And that's the big secret. The LLM itself is completely stateless. It has no memory of what happened before. It's our application that's doing all the heavy lifting, keeping track of the full conversation history and sending it back with every single API call. So it's less like a true memory and more like giving an actor the entire script up to their current line. Okay, so now we get how the conversation works and how the whole memory thing is managed, but how does an LLM go from just spitting back words to actually understanding the meaning of our questions and our database schemas? This is where we have to make a bit of a mental leap. A traditional keyword search is literal. You search for laptop, you get results with the word laptop. But semantic search is different. It's about meaning. It knows that laptop, notebook computer, and portable PC are all basically the same idea. And LLMs live and breathe in this world of semantic meaning. And the magic that makes this possible is something called embeddings. It's a fancy word, but the core idea is that the model turns text, any text, from a single word to a whole document, into a list of numbers, a vector. And here's the really cool part. In this weird, high-dimensional math space, concepts with similar meanings end up closer together. It's how the model knows that best paid is semantically related to highest salary. This is the secret sauce. So we've got the conversational API, we have the memory trick, and we've got this deep semantic understanding through embeddings. Let's put all the pieces of the puzzle together and see the payoff. This is where it gets really powerful, talking to our data. So here it is, a perfectly normal human question. No select statements, no order by, no limit one, just plain English. We take this question, give the LLM the context of our database schema, and let it go to work. And look at that. It's perfect. The LLM understood the meaning of best paid, figured out it needed to join the employees and salary tables, and generated a flawless, ready-to-run SQL query. This is what we call natural language to SQL, or NL2 to SQL, and it is a complete and total game changer. So let's do a super quick recap. We talked to LLMs through a structured API. Their so-called memory is really just a clever trick, where our application keeps resending the chat history. The model's understanding comes from embeddings, which turn meaning into math. And all of that comes together to enable incredible applications like NL2 SQL.
This is really just the beginning. I mean, if we can have a natural conversational back and forth with our most rigid, structured systems like databases, what does that mean for how we're going to interact with all of our technology in the future? It's a pretty wild thought to end on.
I hope you enjoyed that deep dive. If you found it useful, do me a favor and share it with a colleague who's also tired of writing SQL. And of course, make sure you subscribe for more explainers just like this one. Thanks for watching.